7.24. At a hydroelectric power plant, the water pressure head is at a height of 300 meter and the water flow available is 100 meter cube per second. If the turbine generator efficiency is 60%, estimate the electric power available from the plant. G, that is 9.8 meter per second square. Now the height, that is 300 meter. Now the volume of the water available per unit time, that is 10 raised to 3 meter cube per second. Efficiency, that is 60%, and G, that we have to take 9.8 meter per second square. Now hydropower, power, that is work upon time, but work, that is force into displacement. But we know this thing, pressure, that is force upon area. Pressure, that is force upon area. So force, that is pressure into area. So we can write work done, that is pressure into area, and now displacement. So area into displacement, that is volume. So here we can replace work by pressure into volume, time as it is. Now pressure exerted by the liquid column having height equal to 300 meter. In standard 11 in fluid mechanics we studied this thing, that pressure is H rho G, and the rate of volume, that is given to you 10 raised to 3. Now H, that is 300, the density of water, that is 10 raised to 3, and G, that we have to take 9.8 into 10 raised to 3. Solve this one, you will get hydropower. Now how much power is converted into electrical power? So here efficiency, that is given to you 60%. Okay, so efficiency, that is output power upon input power. Okay, so output power, that is efficiency into input power. Now output power, that is electric power. Input power, that is hydropower. So we can write now electrical power available, that is efficiency into hydropower. Efficiency, that is 60%, means 0.6 into hydropower. Here it is calculated, substitute its value, and now solve it, you will get the answer. Clear?